Welcome to the Real Python Podcast. This is episode 95. What are ways you could speed up Python? Have you thought of using a JIT, just-in-time compiler? This week on the show, we have Real Python author and previous guest Anthony Shaw to talk about his project, Pyjion, a drop-in JIT compiler for CPython 3.10. Anthony's been working on Pyjion over the past year and recently released version 1.0. He talks about how he took over the project from Bret and Dino Viehland. He covers the background on compilers and assembly he needed to take on this project. We discuss where a tool like this can speed up your Python code and alternative solutions. We also talk about his desire to make the project as deeply compatible with Python code as possible. Anthony talks about how his dive into writing the CPython Internals book led him into the project. He describes what type of developer would benefit from exploring the book. We also cover his recent Real Python article titled Advanced Visual Studio Code for Python Developers. It's an excellent resource VS Code users should bookmark to revisit as they grow with the tool. This episode is brought to you by Honeybadger. Honeybadger offers error monitoring, uptime, and cron monitoring, designed to tame your production and make you a better, more productive Python developer. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Anthony, welcome back to the show.
Hey, Christopher, how are you?
Doing great. It's very winter here, and I was looking at your pictures on Twitter of dogs playing in the surf and being a little jealous.
Yeah, it's in the middle of summer here, so literally the opposite. So
yeah, that's pretty funny. So since we last spoke, you are working at Microsoft. So what are you doing there?
Yeah, so I'm a cloud developer advocate, and in 2 weeks' time, I'll have been here for a year, which seems crazy because it's gone past so quickly.
I bet.
Yeah, it's quite difficult to pin down exactly what I do, actually. There's just so many things from week to week, but really the focus is looking at how Python developers interact with Microsoft Clouds, which Azure primarily, and also Visual Studio Code and the Python tooling around that. So I kind of sort of try and put myself in the shoes of a Python developer and use the products and services and like interact with them and just look at the documentation and tooling and see what can be improved and work with different teams to do that. And then also do things like share knowledge about the right way to use it in the form of blog posts or documentation or videos, or sometimes I just get stuck in and actually work with the engineering teams to change the product.
Okay. So they might bring you over to cover some of these things that people are discussing, and you would present them the way that you feel that other users are using it and could help improve their situations.
Yeah. So for example, I've got a platform called Azure Web Apps, which is where you can run, Flask or Django or any kind of Python web app and without worrying about the server infrastructure. So you basically just have your package and your requirements file, and it does all the rest for you, it hosts it all for you. And what I really wanted to do was to use the debugging features in VS Code, but to debug the actual live server. And that wasn't something that was supported. So I basically just worked on implementing that, and that was rolled out late last year. So that's an example of I guess fixing something that seemed like it could be improved.
Yeah, that sounds cool. Like I see you working on lots of projects, and I have kind of like three that I wanted to try to talk about, depending on how much time we can devote to it. You recently had an article on Real Python about VS Code, and so I thought we could talk about that a little bit. And I think that might be kind of a touchstone a little bit, kind of talking about the sort of development tools that you're using.
Mm.
And then you've been working on a project called Pyjion, and I thought we could talk about that. And then also the CPython Internals book that came out since since you were on.
Yeah, great.
I thought maybe we could start with Pyjion. there's an interview that you did with Michael Kennedy on Talk Python. It was in November, and I'll include a link for that. And it kind of goes in a much deeper dive into it. The whole show is about that. But I wanted to talk about like how long have you been working on Pyjion? And I guess maybe we could start with like an overview of the project.
Yeah. So Pyjion is a JIT compiler, which I guess we can explain what that means. But
sure, yeah.
So Pyjion. So when you run Python code normally, if you're running the Python that you get from python.org or the one that comes with your operating system, when you type the Python code in and run it, it kind of interprets that code on the go, reads it and compiles it essentially into like a cache format, which is what you see in those PyCache folders.
Yeah.
PYC files. So it puts them in this sort of cache format. And then when you run the code, there's an application that basically goes through those cache files and then decides like what to actually do. So, calling functions or adding numbers together, or even like importing and interacting with other libraries, whether that's like NumPy or Pandas. And, more complicated stuff, I guess, like if you're using Pygame, then it's like talking to the graphics card and like,
right.
I don't know.
All those low level drivers and things that need to talk to the...
Yeah, like making sound work and stuff like that. So that's done at runtime. So that's kind of like interpreted, I guess. Whereas if you compare that with some other languages like C and C++, you compile the application into a standalone executable, and it has everything it needs in the executable. So that's a ahead of time compiler, or an AOT compiler. That's
so if someone is writing a program in C++, the step before they can run the program is they have to sort of have it build and compile it, and which is very different from somebody who's using Python.
Yeah, exactly. I mean, like the only language that computers really understand is machine code. They don't understand Python or C or C++ or any of these things. They understand machine code instructions, which are pretty much like they're add and subtract.
Yeah, right.
And multiply. Like everything has to be boiled down to these really low level instructions at the machine level. And so what Pyjion does is basically it compiles your Python code into machine code. So it compiles it down into low-level instructions that the CPU can just run natively.
And some of the reasons that you looked at doing the project had to do with kind of the two talks that I'll link to here, these conference talks. You had a 2020 talk for PyCon that was, Why is Python Slow? And you described a mathematical problem, this thing that measures the positions of planets, called the n-body problem.
Yeah.
And the way that math is done, and it's very complicated, and Python, in the way that it's implemented, ends up being fairly inefficient in dealing with those types of numbers. And so you talked about this would be an area to kind of improve, and you kind of use that as a way to kind of talk about it again in your 2021 talk at PyCon, where you're restarting the Pyjion project and saying, these are the types of optimizations that I could do that CPython maybe is currently not optimized to do. Am I getting some of the gist of it?
Yeah, that's spot on. Yeah.
Okay, cool. So what I was wondering about is what made you, first off, I can understand the desire to want to make Python faster, but why were you interested in getting involved in this problem?
I originally heard about this because Bret and Dino Viehland worked on this at Microsoft.
Okay.
5 or 6 years ago. I don't know how long it is now. Dino now works at Instagram, Facebook, or Meta, I guess they're now called, and he's working on a new compiler specifically for their needs. And Bret just doesn't have the time to work on this. He works on VS Code. So it kind of got left for a few years. And I was just really interested in the project. Like, as a learning experience, I looked at it and I didn't really understand how it could work or how it did work.
Okay.
And I just wanted to get stuck into something as a challenge and really get to actually work on it and improve it. And I thought that would be a good way to build up my own skills and build up my own knowledge in compilers. And it kind of followed on from having finished the book.
That's what I was thinking about, is that your book, the CPython Internals book, you had to dive pretty deep into how CPython's handling things, and maybe you were seeing some things that, I mean, your research into that book, I would guess, would be a very healthy jumping off point, unlike somebody who's coming to Pyjion cold.
Yeah, so that was kind of the reasoning behind it. I could finish the book, and I felt like I'd gone on this journey to understand something at a really low level, and then it's kind of come to a bit of an abrupt end because I'm not working on CPython, like the core CPython stuff. I'm not one of the core developers. It kind of came to an end, and I wanted to keep digging, and go further down the rabbit hole, I guess. And it kind of cut off, I guess, at the machine code level. So after I kind of finished the book, I was going through a book on assembly. So that was something I never really learned at college. We didn't do assembly at college. We briefly did, but
what would be the things that they would have you do in college in assembly, just as like something to try out?
They would just like add two numbers and stuff. It would, yeah, like I think they explained to us what the instructions were, but that's not really useful in a modern context. Like, you wouldn't actually practically sit down and write. Well, some people do, but you wouldn't sit down and write a program in assembly.
It's hard to parse. I mean, that's one of the huge advantages of Python, is that you can look at it with all of its white space and almost read it, depending on how complex the code is.
Yeah, I did write a blog post, how to write a Python extension in assembly, as a bit of a joke.
Okay.
And like all the steps you need and things like that. And you can import it and run functions that you've written in assembly. But I guess the point is that if you wrote that same code in C and compiled it into assembly, which is what the C compiler does, the C compiler will do a much better job of writing assembly than you will.
Right.
And I think you have to kind of have that mentality, which is, yes, you could write assembly yourself, but somebody's already done the decades of academic research into what's the most efficient way to compile an application down into machine code, and writing it by hand is not the answer. So yeah, use a compiler to do it.
Yeah, and one of the things that was mentioned several times in your conversation with Michael was that this project is using .NET 6, and in that case, you're leveraging some of the things that are inside of that set of tools, that .NET library, to help with these compilation to machine code too, in the sense that, you mentioned in the documentation that you can go ahead and just pip install it, but you still are going to be missing things if you were to try to use Pyjion, because it's going to be missing some of these extra tools, right?
Yeah, so you do need .NET 6 to be installed. This is one thing about Pyjion that confuses a lot of people, and I can understand why, because it is a bit confusing when I bring .NET in as a term. People think it's using .NET, but actually it's not.
The term's overloaded because of the history of like .NET developers and people working and creating Windows applications. I think that it kind of maybe got overloaded as far as the terminology of what it means.
Yeah, so from .NET 5, .NET basically got rewritten completely from scratch. And .NET was always a Windows only thing, and it was like akin to the Java virtual machine. It has its own intermediate language, and it works with high level languages like C# and F# and also C++. You can use .NET from C++. So those are languages that you would write in, and then it compiles down to like this middle language that you never really see, called CIL, C-I-L.
Okay.
And then basically like the .NET runtime, it's called, converts the CIL code into runtime instructions for that operating system and that CPU. So that was always at Windows only, and then they basically rewrote the whole thing over the last 5 or so years what was called .NET Core originally, and then as of .NET 5, that then became the .NET is this new one, I guess.
Okay.
Some people still refer to it as .NET Core, but it's .NET 5 and 6 are the new cross-platform .NET runtime. So with Pyjion, basically, going back to what I was saying about, you could write assembly by hand, but a compiler does a much better job than you would do. So what we need for Pyjion is a thing right. Called a code generator, which will write assembly given a specific input, and it will do optimizations based on what makes sense. So on a CPU, basically you have instructions, and there's the instruction set. So for an Intel CPU, a 64-bit Intel CPU, there's different instructions that it understands, and the inputs are either a constant value, like which has to be a number, or it's loading from a register, which is like a kind of, I guess, like a variable, but it's like a storage area on the CPU. So a code generator basically would do the job of figuring out which registers to use and like where they've been stored. And no matter how complicated the program, it would figure out how to boil it down into the machine code instructions. So like it does all that work for you. I don't have to figure that out. I've got books on that stuff and I've read chapters on it. But like I couldn't write one from scratch, like enormously complicated, and the decades of research by people who are truly experts in compilers have got into that. So what Pyjion actually does is it uses a single component from .NET. It's actually just one library in particular, which is the JIT compiler, which uses the low-level code called SIL and compiles it into assembly code, machine code for Intel CPUs. And recently I've added support for ARM CPUs. So either ARM on Linux or the M1 CPUs on Mac.
Yeah, I was wondering about that. You had a request out at the end of your PyCon talk. I'm guessing either someone hooked you up or you got more information from another team for how to get that implemented.
Yeah. Eventually, I borrowed somebody's computer for a day.
Oh, okay, cool.
I just need it for a few hours, please, just to compile it. So yeah, it supports M1 now. If you want to see, I guess, a bit more of this, if you go to live.trypyjion.com, I've got like a interactive compiler. So basically like how the compiler works. And I've put a demo application in which it's a function in Python that assigns 3 variables, A, B, and C. A is 2, B is 3, C is 4. And then it basically just does like simple arithmetic on those variables and then returns the result. And at the bottom is a compile button. And if you click on the compile button, it will show you the SIL code that Pyjion generated. And then on the right-hand side, actually showed you the assembly code. And one thing you might notice, like most people can't read assembly, or there's no real point in
right.
learning it as a language. Sometimes it's useful, but something that's really important about what Pyjion has managed to do on this demo application is it's looked at the function and noticed that the variable A is only assigned once, B is only assigned once, and C is assigned twice. And what it actually does is it works out the answer to the expression C plus A times B, and it just says, oh, actually, that's just 10. So like that's never going to change. That code can only return the number 10. So what it actually compiles to is return the number 10. So it doesn't even bother creating any of those variables at runtime. It basically just optimizes the application by noticing that it can only ever return a single value. So the assembly code on the right-hand side basically just says, return the number 10 as a Python object, and then that's it.
Cool.
So yeah, it's a lot faster. So that would be, I don't know how many times faster, probably 10 or 20 times faster than what Python would normally run that code at.
And some of what's happening inside Python that makes some of these numerical things a bit slower is just the way that these things need to be turned into versions of Python objects that have lots of additional, they're literally objects. They have all kinds of methods and other things that can be applied to them that kind of go beyond something like a simple integer in machine code or whatever. So this is going to help kind of streamline some of that if it can recognize where to do it. Is that right?
Yeah, that's right. So numbers, I guess for math, you've got floating point numbers and integers.
Yeah.
And in Python, you've got both of those as well. So you've got the int type and you've got the float type, which is a 64-bit floating point number. So those are great, but when you actually work on the CPU level, so like if you times two floating point numbers together, so like 1.5 and 3.0, for example, if you multiply those in Python, what it will do is it will get the floating point number, ask the CPU to multiply them, and then it will turn that result into a new object. So it has to allocate the memory to do that. Python's got like a whole system for managing object allocation and memory and stuff. So it's very efficient in the way it does that, but still it's slower than if you'd have written that in C or C++, because C and C++ would say, oh, a 64-bit floating point number is actually just a single CPU instruction. So let's not bother allocating memory because a 64-bit number fits inside a 64-bit CPU. Like when you say a 64-bit CPU, that's because the registers, like these temporary storage areas that I talked about, they're 64 bits wide. So like just put the number in the register and multiply it as like two instructions. Whereas when you run that in Python, it's got to allocate the memory, create the object. Like it's going to do thousands of things.
Yeah.
Instead of just one, I guess.
Let's face it, your Python code is amazing, but it's still going to have errors. When errors do happen, it's nice to know Honeybadger has your back. Honeybadger sends you alerts in real time with all the context needed to see what's causing the error and where it's hiding, so you can quickly fix it and get on with your day. The included uptime and cron monitoring lets you know when your external services are having issues or your background jobs go missing or silently fail. Go to honeybadger.io and start being your team's or your own DevOps hero today. That's honeybadger.io. I'm kind of stuck on this .NET thing a little bit.
Yep.
And I what I'm wondering about is the workflow of using Pyjion and to be able to take advantage of it is that you would import it and then you add one additional command. Is it Pyjion execute? I'm trying to remember what
Enable.
it is.
Yeah.
Enable. Okay. And then once you've called that, it's now going to look through your code, you know, as you're running it as far as for these optimizations. And the optimizing is happening. It's creating the SIL code. At the same time, I'm guessing there's something in the background that's sort of running to look at the SIL code and then compile those things. The components of the .NET stuff is running to look for that on that particular machine where you have all this installed.
Yeah. So in Python, everything is an object. So, you know, strings are objects, integers, floating point numbers, classes are like instances of classes are all objects, including functions. So they're called code objects in Python. So if you have a function that you define, and then when you run that, that is a code object. And it has properties like it has which variables are in there. Are there any constant values? So like you can look at the code object in Python
with the dis, right?
Yeah. So dis will actually like disassemble the bytecode in there.
Okay.
What Pyjion does is it actually adds a few extra fields to the code object. So the bytecode field is already there. That's the thing that Python creates. And then what Pyjion does is when that function is called, when Pyjion is enabled, it looks to see if these extra fields exist. And if they don't, then it will basically go through the bytecode and compile the bytecode into SIL, which is the .NET. Like it's basically bytecode, but for .NET.
Yeah.
But it's a lot lower level. So bytecode in Python will have like there's one instruction, for example, for merge dictionaries, which is actually quite a lot. there's a lot going on there.
Okay.
So the .NET bytecode is a lot lower level. So it compiles down into the .NET bytecode and it stores that as a attribute of the code object. So
Okay.
what you don't see, I guess, when you run Pyjion is that your functions have a few extra fields in them. One is the .NET bytecode, and then the second one is the actual machine code. So like, and it's like almost like a standalone executable. So it turns each function in Python into its own little program.
Cool.
And then when you run the function, it tells CPython, oh, you don't run that function now, I do. And Pyjion will basically like call that little standalone code and run it. So whenever you run the functions, instead of interpreting the instructions in the function, it will actually just run that standalone application.
Wow. That's cool. In a circumstance, what I'm wondering about is, I guess, maybe the portability of something like this. In your live trypyjion.com example that's running as an Azure function.
Yep.
And so it would have the .NET stuff available in that install of how that's configured. But I'm wondering about, like, if you wanted to move this code around, the SIL code can be compiled on these other machines, depending on the installation. Like if it's running on a Mac, it's going to have different machine code than it's on an Intel, and so forth. So I wonder about like that, like what sort of things would somebody need? Like if they wanted to, they're doing lots of mathematical stuff and they could see this as a handy way to speed up that code. And they say want to run it in the cloud or run it using something like Docker. Would there be lots of steps to kind of set that up?
So that's actually when we started talking about this, I mentioned it's a JIT compiler, a just-in-time compiler, and I said we'll come back and explain what that means. So basically, like that is what it means. Just-in-time, it compiles all that stuff like the SIL and the assembly code specific to the CPU that it's running on. It does that when the function is called. So when you define a new function and you run it when you've imported Pyjion and enabled it, it will then compile all the stuff. So it will compile the SIL, it'll compile the assembly code, and it puts all that stuff in memory.
Okay.
So you don't have to worry about portability because it figures that stuff out on the fly. And what makes sense for the CPU that you're running on, like what features it supports, and if it's an ARM CPU or an Intel CPU. And there's also other details about like which Intel CPU it is and what instructions it supports. So it figures all that stuff out for you on the fly.
Okay.
The things you need to have is the .NET runtime install, which you can install on Linux, Mac, and Windows. It's actually not even the whole .NET runtime. It's actually just one library that it needs. So in the Pyjion GitHub project, there is a Docker file in there.
Oh, okay. Great.
So that's like an example of how to run Pyjion in Docker. And the way you install .NET is actually just download a tarball from the .NET website and just extract it and tell Pyjion where you've extracted it. And it will look in there and find the library that it's looking for. So that's really all it needs.
Yeah.
It does need Python 3.10 as well, which, when you talk about running on the cloud, gets a bit tricky because
yeah, I can see.
3.10 is pretty new, and like not all clouds support 3.10 yet. So yeah, the live.trypyjion.com is actually a Docker image at the moment. So yeah, the source code for that as well is on GitHub. So the application that runs this is just a simple Flask app. And yeah, Pyjion was designed to be portable. So, you can run it in a serverless environment, you can run it in Azure Functions, for example. You can run it in a Docker image. You can run it in a VM. Anywhere that would run CPython would also be able to run Pyjion because it is just an extension that you pip install and load. Like you need to have one extra thing, which is the .NET library on the machine.
Yeah.
But like other than that, like it's just a thing that you pip install. So it's different to, I guess, other projects like PyPy or Cinder.
That's the meta one, right?
Yeah, it is. So they're like other Python interpreters. So instead of running Python, you run Cinder or you run PyPy. Like it's like a whole different application you have to run to run your Python code. Whereas with Pyjion, you just run Python and you pip install Pyjion. And then before you run your code, you call a function to enable Pyjion.
Yeah.
And then it does the rest for you.
So that kind of covers one of the things that you mentioned in your talk, kind of the design philosophy behind Pyjion, which I'm not sure if that was the design philosophy when Bret and Dino were working on it originally, but you had put this compatibility, as a bit of a focus.
Yeah.
So I wonder about that. Like, is that a change from how they had focused on it, or is it kind of the same?
Probably is a change. When it was originally written, it only worked on Windows.
Okay.
And it required a custom build of Python and a custom build of .NET, only because like at the time, like it was technically impossible to do what they were doing. Like it was built as a proof of concept.
Okay.
So yeah, I kind of, when I sort of forked the project and then redid it, I looked at the other, I guess, competitive projects to Pyjion, and there's like Piston and PyPy, and I'm like, okay, so why would people use Pyjion over those? PyPy is probably the most obvious one because it's very efficient. It's been around for a long time. But the reason people often can't use PyPy is because it's not compatible with their whichever libraries they're using or which C extensions they have. So I kind of wanted to make it clear that with Pyjion, I want to make sure that any code that runs in Python would also run in Pyjion.
Yeah, that makes sense. And you had mentioned in the other interview how you had tested it across quite a few libraries just to confirm that it's only going to optimize what it can optimize. That's kind of part of the design philosophy, also, right?
Yeah. So part of I guess the downside of making it compatible with as much as I can find is that it won't be as aggressive with the optimizations. So PyPy is really good with optimizations, but there are some drawbacks with compatibility on that. And the same with Piston and some of the other projects. So I kind of wanted it to be almost as transparent as possible that it's optimizing, which has drawbacks that, it can't be as fast as it would be otherwise. So, for example, I'm working on pandas at the moment and trying to see where Pyjion can make pandas faster.
Okay.
Which is a really tricky problem because it's such a big and complicated library. But it imports pandas and it runs all the C extensions, and like that works out of the box. And NumPy, it works with NumPy, and
which is pretty fantastic already.
Yeah, which is like, and the first time I actually ran it in Flask, it just worked, and I was amazed because it was like during a live demo.
Oh, that's cool.
And I was like, oh, I wonder if you can just like run the whole of Flask with Pyjion enabled, and it just like it JIT compiled down into machine code like the whole of Flask, and it just worked. And I was like, oh, that's pretty cool.
Yeah, that's great. So I kind of don't take this the wrong way, but like I think that compatibility thing is not completely at odds, but somewhat at odds with saying, hey, this needs Python 3.10. And that might be partly to do with just where the language is at with 3.10. So maybe you could talk about that a little bit, like why you're requiring that.
Yeah, so where Pyjion comes in is I mentioned the Python bytecode. So in a code object, it's got the Python bytecode. Python bytecode is specific to the version of Python.
Okay.
This is the hard bit. So in Python 3.7, 8, 9, 10, and 11, actually, which is, coming out later this year, they changed the bytecode. So like they add new bytecodes or they take away old ones. And like normally that's just an implementation detail, but I care a lot about that with Pyjion because I have to use the bytecode to decide what that function should do.
Right.
And basically just for my own sanity, I decided that I'm not going to support multiple versions of Python because I'd have to maintain multiple branches of Pyjion with supporting different versions. And also, like 3.10 is a great release and it made a lot of advancements in efficiency. So the compatibility thing is important, but obviously it only supports the latest version of Python.
I can understand it too. Like this kind of relates into something that you did at the end of your talk where you're asking for help. You're like, hey, I'm looking to see if other people would want to help in that. And I'm kind of wondering how that's gone for you. That was back in, I guess, May or April of last year. Have people reached out and come to help you on the project?
Yeah, a few people have, and providing test cases and trying it out, which has been really helpful. So running Pyjion over more libraries and packages. Actually, somebody ran it over the Django test suite, like the internal Django test suite. That was really interesting, and uncovered some kind of like quirky bugs and stuff like that that took me a while to fix. And that was like a really complicated problem to tackle as well. There's somebody who works on the hypothesis library, which is like a test. I don't know what you'd call it.
It allows you to generate lots of different like data and different
fuzzer. That's it.
Yeah, fuzzy information. Yeah,
yeah. It's a test fuzzer. So somebody who's trying to run both hypothesis and the hypothesis test suite with Pyjion enabled, which is like, again, a really complicated problem. So that's been really helpful. But in terms of people actually contributing to the guts of it, like the code, there hasn't been anybody yet. There's been lots of people who are interested. Just that this is one of the challenges is that the learning curve for it is pretty steep. And this is one of the challenges, I think, with like why Python, the compiler itself, like, there's so many things you could do to make it more efficient, but like to get to a position where you can work on it, like there's so much you need to do and there's so much you need to research and read and understand in order to get there.
Yeah.
It's such a steep learning curve. It eliminates a lot of people, partly just on the experience side, but also time. Like, not everybody has the time to study for a year about compiler theory to get to the point where they can work on it. Like, that's not really fair.
Yeah, that's hard.
Yeah, so that's why when you look at people who are actually working on this stuff, so the people on Meta who are working on it, like there's like a dedicated team of engineers working on optimizing Python. So like that's where their project came from. And now Guido at Microsoft is leading a team, Mark Shannon, who are working on optimizing Python as well. So like, and they're people who are dedicated engineers, but they've also got like decades of experience working on compilers. It's a very niche part of technology and requires a lot of research, I think, to get stuck into.
Yeah.
I mean, millions of people use Python, and like you can read the source code, but like the guts of, okay, how do we make this more efficient? Like there's so many things you need to know in advance. Yeah, that's kind of what makes it hard.
Yeah, I can imagine. Like that brings up like about 5 different things I could think about to ask you. But like when I had Lucas on, and he's working pretty hard as developer in residence, and he admits himself, like he's like, I don't know everything that's in the in the source code of Python down and all those levels and those different libraries and so forth. And he's been working in Python, for a very long time. So I kind of wonder, like, what would be, I guess you kind of mentioned some of them, but what would be like prerequisites for someone that if they were going to help with creating some of these optimizations? Because you have like 17 optimizations that you list that Pyjion can kind of help with to kind of make your code faster. If someone was potentially going to help you with that, like what sort of background would they need?
But knowledge of assembly is one thing.
Okay.
Unfortunately. So, when you're debugging Python code in your IDE, you can set a breakpoint, when you run the code and you can see what the variables are and stuff. When you debug JIT code, you're debugging assembly.
Okay.
Because there was no code that, like, you can't actually see like high level code because there wasn't any. So this is like one of the really tricky things with working on Pyjion and JIT compilers is that you spend a lot of time looking at assembly code. So that's one thing people would definitely have to do. I would say I taught myself assembly over a few months, and it wasn't, I'm not an expert by any means, and it sounds really scary. But I think with a good book, let me find. I've got mine's Joe Van Huey. It was the guy who wrote it, and it was x86-64 specifically. Like, don't just read the x86, the old 32-bit books because it's irrelevant with modern CPUs. Get a 64-bit Intel architecture assembly book, but that like teaches you how to write assembly code from scratch and like how to write actual programs and like how to import libraries and stuff like that. So that's cool. That's really helpful. And also knowledge of the .NET CIL, which is something you can learn pretty easily. It's not too complicated. And then C++ experience, because Pyjion is all written in C++. So yeah, those things.
And you've been writing in C++ for a while?
Yeah, it's actually one of the first languages I learned. So I've kind of been using it for a long time, on and off. Yes, since I started coding, really. So, and yeah, it's akin to C, but yeah, I guess with objects and lots of other quirks.
all the add-ons, yeah. Cool. Would there be other types of help that you'd be looking for?
Yeah, people just to use it and to try it out and run it with test suites and find bugs and stuff like that. Like that's really helpful for me.
Yeah.
People who've submitted issues where they run it on a test suite and, you know, the test without Pyjion would pass and the test with Pyjion would fail, and it's all reproducible, and, you know, I can understand why it's done that. That's kind of what I'm looking for at the moment.
Cool.
Like I think the optimizations that are at a point now where they're, you know, getting mature, it just needs to be worked on. The actual stability and the compatibility needs to be as a focus at the moment.
Yeah, that makes sense. Where do you find the time to work on this? Because I can imagine it's a pretty big investment.
Yeah, I'm probably working at like a few hours a week at the moment.
Okay.
Part of my role, I do actually have an allocation of time to work on open source projects, and I use it to work on this. So yeah, I can't remember what percentage. I think it's like 15 or 20% of my time.
Okay.
I can work on open source projects, and that's what I do on this. And sometimes I just get stuck into it for a day or so, and then make the time up another time. So yeah, it's a lot of work, but it's, you know, this is all spread out over a year or a year or so.
Yeah.
And a lot of the stuff with Pyjion and these kind of projects, I guess, is like working on it for an hour and thinking about it for a week.
That's pretty common, right?
Yeah, there's a lot of those kind of problems where, like, and that's something that I've taught myself over the years, is that when you get stuck on something, identify where you're not going to make any more progress at the computer. Like,
yeah,
I've been looking at this problem, can't figure it out. I'm getting really frustrated, so I'm going to go and do something else. Like, I'm going to go and work in the garden, or, you know, I don't know, take the dog out or something.
Right.
And then I'll leave it for a week, and then, you know, a few days time, often in the shower or like when I'm walking or something, I'll you just kind of figure out the answer in your mind, or you're like, oh, I wonder if it was because of this. And yeah, there's been, I can't remember which scientist it was, but like said that like most of their scientific discoveries were made like whilst doing a walk around the garden, and not in the laboratory.
Yeah. Yeah. No, I've experienced that a lot, and very often to take people away, like if it's a project with multiple people, to take them all away from the computer for a little while and like sit and just kind of talk about it a little bit, like can make things pop out in kind of interesting way too. Like I've always tried to do that with people when I was building projects for them. Like, okay, let's just all get away from the computers or screens or whatever, and just kind of like talk about, well, how are you using this and like what's happening, and then like can kind of come up with really interesting solutions. So it's it's kind of surprising the way your brain works.
Yeah, no, it is. Yeah, it needs to think of things. Asynchronously.
Yeah, definitely. It's an asynchronous process. Yeah, I'm really impressed with the project, and I definitely want to play with it some more. And I definitely will put the call out here for people that if they're interested in helping in those ways, that they should definitely check it out. And I really like the site you have, the live site, so that people can get a better visualization. It's always hard on a podcast to sort of explain, like, you know, okay, well, what does, you know, machine code look like, or what does CIL code look like, or kind of what's happening there. I like that part of the project that you've done. That's really great. So the CPython Internals book came out, I guess it would be 2020. I don't remember the exact timing. And I guess like the subtitle of it is your guide to the Python 3 interpreter.
Mm.
If you were going to pitch somebody on it, like who is this for? Like who should be interested in diving into the internals?
So a few different audiences. One would be people who are wanting to write C extensions
Okay.
for Python. I think if you do write, it doesn't teach you like all the APIs and stuff you need to. I think there's plenty of places to learn that, but you do need to know like how Python works to write C extensions. That's kind of one audience, I guess. And the other audience is people who are like intermediate Python programmers. So like they've been using it for a while, but it's still a bit of a black box. So like you allocate objects and you create objects in loops and stuff like that. But like how and why it does things, it's still a bit of a mystery. So it's really for people who are curious to learn a lot more and open up that black box and understand it. And when we talked about like the prerequisites for contributing to Pyjion, like there's so many, and it is a bit of a steep learning curve with Python like internals. If you wanted to contribute to Python itself, like the actual CPython project, if you wanted to, submit pull requests and make improvements and things, like that's brilliant, and people should absolutely do that. This book would be ideal. Like it would teach you all the things you need to know about how like Python works and what, how the source code is structured and how it allocates objects and things. So it's either if you want to contribute to Python or if you just want to push yourself a bit and to learn something different and get into the guts of a big, fairly complicated application. But I don't want to make the book sound scary, because the way it's been written is to essentially describe how Python works, but in a way which is approachable and accessible to anybody, really. Like, I spent a lot of time on each individual chapter. Like, how can I explain memory allocation, or how can I explain multi-threading, for example, like in a way that's easy to understand for people who don't know these concepts. So there's no assumption when you get this book that you know anything about compilers or
right. Okay.
Even C, actually. Like Jim on the Real Python team wrote an extra chapter, like a bonus chapter at the back of the book, which is like quick guide to C. Like
yeah.
Here's enough, how to read it enough to figure out kind of what's going on. So there's chapters on like, how it actually turns the language, like the code you've written, how it turns that into something that it can understand. And there's also practical exercises in the book. So one of the things you do through the chapters is you add a new feature to the language.
Okay.
So, when you're writing a Python expression, like if A equals B or greater than B, like those are like expressions you write. And we introduce a new one, which is using the squiggly line on the keyboard, or the tilde, which is above the tab key, I guess.
Just below the escape. Yep.
Yeah. anyone who played a lot of Quake will know that key.
Sure.
So we basically add a new operator, which is tilde equals, or we call it almost equal. And basically what you'll do in the book is actually implement that as a new piece of syntax in the Python language and compile and make your own custom version of Python that supports this almost equal, so that 1 almost equals 1.01. Like they're pretty close. So
okay, yeah.
And we implement it for strings as well. So like hello with a capital H is almost equal to hello with a lowercase h.
Right. Okay.
So like the actual practical stuff, not just reading the source code, but actually making changes to it as well. And then talking about performance and how does this async and await actually work, and how do coroutines work, and like it digs into everything really in Python and explains how it actually fits together.
I feel like I've been doing this program for almost 2 years now, and I had like another like year and a half or so kind of before this. And so I've kind of been ramping up my knowledge. And again, I've kind of bounced around to lots of different languages, but interviewing people, talking to people like Bret about his Unraveling series and getting tastes of kind of like what's happening inside of these different things. I feel like I'm now at that moment like, okay, I'm ready to like explore it. And one of the things I was wondering about was okay, you spent some time talking about it, but I thought maybe we could mention it here is like, you're going to be running C, right?
Yeah.
So what type of editor or what kind of setup does a person need to be able to do the examples and kind of go through the book?
Yeah, that's all explained. There's a chapter on like how to set up editors and things. So you can choose between Visual Studio Code would be one. So there are both in Visual Studio Code, there's extensions for Python and for C or C++, and you can set it up so that it can compile and understand all of the above.
Okay.
Yeah, that's actually some of the core developers are now using VS Code as like the tool to kind of tie things together. Or you can use like a console editor like Vim or Emacs if that's what you're used to. I wouldn't recommend if you're starting from nothing jumping in and picking a tool like that because they're pretty hardcore. But I do explain, okay, here's all the customizations you should probably make to Vim in order to get like everything up and working. Another option would be CLion, which is the JetBrains IDE.
Okay.
So PyCharm is fine, but like the C and C++ support is very minimal. Like you can just read the code, but you can't actually compile the project.
Oh, okay.
So CLion is their equivalent for C and C++, and that works really well with a CPython source code. There's no community version of CLion though, so that's a paid product. Yeah, but I do kind of talk about that in the book. And if you're on Windows, there's Visual Studio as well, which is like has full C and C++ support. So you can, and there's also in the CPython source code, there's also a Visual Studio project already pre-made that you can just open, and it's got everything there.
Okay.
Because the people who work on the Windows parts of CPython use Visual Studio to edit it. So like, you kind of get the advantage of all the tooling. I don't know what the majority of core developers use. I think a lot of them use Vim or Emacs as like a text console editor, but only because they've been using that forever and they know all the shortcuts and stuff. But
yeah. This week, the spotlight is a bit different. I want to let you know how you can check out the book that Anthony and I have been talking about on this episode. There's a 75-page preview of the book available at CPythonInternals.com. It's your guided tour through the Python interpreter, and you can unlock the inner workings of the Python language. Here are a few highlights and goals of the book. You'll be able to read and navigate CPython interpreter source code, make changes to the Python syntax and compile your own version of CPython from scratch, master CPython's memory management capabilities, debug C and Python code like a professional. And it's a great start if you're interested in participating in the development of CPython. CPython Internals is a great and unique resource for anybody looking to take their knowledge of Python to a deeper level. And Guido van Rossum, creator of Python, said, "I can recommend CPython Internals to anyone who wants to get going with hacking on CPython." Check out Anthony Shaw's CPython Internals, and don't forget, there's a 75-page preview of the book available at CPythonInternals.com, and there's also going to be a link in the show notes. I kind of wonder about that. It kind of leads almost into your article for Real Python. But I was when I talked to Bret Cannon a couple weeks ago, he felt at the time that he was more of a code editor person, somebody who had been using like Vim or Emacs and things like that. And that's how he uses VS Code now because it's sort of portable in a way, unlike something that's a full-on integrated development environment. And I kind of wondered, like, where do you fall on that spectrum? Are you more of a like full-on integrated development person or a code editor type person?
Yeah, I definitely said I used to be more of a full-on integrated development person, but now the projects that I work on span across different technologies. So
sounds like it.
It's almost impossible to like, in a single day, I'll be working on JavaScript, HTML, TypeScript, Python, C++. So like, unless I have 6 different IDEs open all at the same time,
right?
And my machine, my main workstation's got 32 gig of RAM, which sounds like a lot, but on some days is really not enough, which gets a bit crazy. And it's just everything grinds to a halt, and it's really not great. Whereas I've kind of been using VS Code now for the last couple of years, I guess, and pulling in like all the extensions that are specific to the tech stack that I'm working on. So now I really tend to have like a few VS Code windows open, working on different projects or different environments and stuff like that. And then I've got I've got 91 extensions in my VS Code.
All right.
Which I should probably cut down at some point. But yeah, basically like to do pretty much everything, whether it's like editing Markdown or working on C++ or working on TypeScript or anything like. So I kind of almost like built my own custom IDE in VS Code, if that makes sense. So like,
yeah, it's like a multi IDE or whatever.
Yeah, so it kind of basically does everything for me now, and I can just kind of stay in the one tool. And the thing I like about it is that it loads the extensions that it needs.
Okay.
So if you're working on a project, if you're working in a folder and it only has Python code, it's not going to load up the C++ extension. Like it doesn't do that, which is good. So like it's still fast. Like it's quick to start, and like I can still use it to edit like a markdown file and stuff like that. And it's still going to be pretty quick.
Yeah, cool. Kind of going back to the book a little bit. Why did you take on that task of writing the book?
Probably similar to Pyjion. I think it was just like I kind of dabbled with the internals of Python for a while, and then just got really curious and worked on an article for Real Python, and it was like a deep dive into the source code.
Yeah. Okay.
And then had a chat with Dan Bader at the PyCon in 2018, I think, maybe 2019.
Okay.
And we talked about the article and then agreed to turn that into a book.
Expand it.
Yeah, I was like, well, if I was to write it all again, like, yeah, there are different ways of approaching things, and like I'd want to use a lot more, like make it a lot more visual, the book, to explain like complicated concepts and stuff like that, and try to condense it down a lot so that you're not looking at source code, you're understanding concepts. So yeah, it was really just something I wanted to do.
Yeah, cool. So this article that you wrote recently, the Advanced Visual Studio Code for Python Developers, that one, I've kind of gone through a lot of it, and it's an interesting guide. It's one of these things where you wanted to show, it seems to me that you wanted to show like a huge like swath of like, well, these are the ways that you could customize it and kind of give people different directions. Like, how do you see someone like using this guide?
I as a bookmark,
okay,
as a reference for later use. That's definitely what I use it for. Even though I wrote it, like I've bookmarked this, and specific sections and chapters like send to people all the time. People are asking, how do you do this? Or like, what would be the right way to do this in VS Code? I was like, okay, well, here's the instructions. Just, follow this section of the guide.
Yeah.
You could read the whole thing start to finish if you want, but like it basically tells you how to take like VS Code out of the box is an editor.
Right.
It's a code editor.
Similar to like Sublime or something, fairly simple text editor. It's very expandable though, as we discussed so far.
Yeah, exactly. And this kind of shows you how almost like actually like how I've set up my environment. So it kind of expands on like, okay, how do you customize the user interface and the built-in terminal, and like how should you lay out your VS Code settings so that you can commit them to Git so that other people on the team have got the same rules, but they don't get, confused with where you've got things installed, and like linting and formatting code and like basically like customizing the whole environment to be specific to your projects.
Yeah.
And like you can do so much with it. Like I talk about tasks, for example, which is like a built-in feature where you can define what scripts to run, or like, I don't know, like if you need extra things, like for Django, for example, like there's all those Django commands like compile, static, and make migrations and stuff. Like you can define those as things that can be run automatically in VS Code, and it will go and do that stuff for you in the background.
Yeah, I liked how you talked about, it's been a common thing lately to talk to people about packaging up their code and sharing it for distribution. And so you said, well, you could set it up to have like a task system that would, build a wheel or source distribution if you wanted.
Yeah, definitely. And then one big part of it is the remote development with containers, which is such a cool feature.
Yeah.
Like you can take a project, so you've created a Fast API app or a Flask app or whatever, and you want to turn that into a Docker image. You could do it the old school way, which is like create the Docker file, run Docker build, run Docker run, and then like see if it works. And then it doesn't. Okay, I need to go make some changes, and then run build again, and then so like it just that like cycle just is really slow.
Yeah, definitely.
So VS Code will basically like restart itself, but it will basically put itself inside a Docker container, so that like you're editing the code in the container, and when you run the debugger, it's like running in the container. So you basically it's a much more efficient way of writing Docker containers and building applications which are to run in Docker is to just build them natively in VS Code with the remote container extension, and it also writes the Docker file for you. So like it's got templates and stuff as well, which is really cool.
You were just talking about like how many extensions you had. Was it 90? You said,
yeah.
And you kind of talk about some of your, I don't know if they'd be your favorites, but your bonus extensions. There's a little section there.
Yeah, it's like spell checkers, and there's a Docker extension as well, which is like managing your local Docker environment. One of my favorites is Thunder, which is like a REST API client. So if anyone's ever used Postman or anything like that, it's basically a GUI for creating HTTP requests.
That's great.
To a REST API, but it's like built into VS Code. So yeah, when you're working with Fast API or Flask or Django REST framework or something, if you want to do some testing when it's running, you just install Thunder client and create the requests and just do it all inside the editor instead of switching tools.
Yeah, that I was using Postman, and I don't know, something had changed with it recently, and this looks like a really great way to kind of keep it all in this environment already, which is nice.
Yeah.
And then of course we got to talk about your own personal extension, the VS Code Pets.
Yeah, so I mentioned at the end, so I made an extension to VS Code, which amusingly is like become really popular.
Yeah, I know. Are you becoming known for the Pets extension?
Yeah, I was talking to my wife about like, she's like, how's things going at Microsoft? And I was like, yeah, it's great. But I'm worried that like people are going to know me as the person who made the Pets extension.
Yeah.
I've got like 36,000 installs now. But yeah, it was just made for a bit of fun, but it kind of brightens up your VS Code a bit. So it adds a panel in VS Code, and you can add pets to the panel, and they wander around and they make friends with each other. And
you can have multiple ones in there.
Yeah, and you can like throw a ball and they'll like play catch and stuff. And yeah, they just generally just like goof around in this little panel. And there's lots of different pets. There's like cats and dogs and snakes, and people are adding new ones all the time.
Yeah, I keep seeing new ones in there.
Yeah, so that kind of makes it fun.
That's cool. So I have these weekly questions. If you still have time to kind of go over them.
Yeah, shoot.
Okay, so the first one is, what is something that you're excited about in the world of Python right now? And that could be an event or a package or a book.
I'm really excited about Python 3.11.
Okay.
That's going to come out later this year. Just following all the advancements that are being merged in at the moment. I think it's going to be a real milestone release for performance in particular. I think it's going to probably be the biggest step up in performance that we've seen probably ever actually in Python, to be honest.
Wow. Yeah, cool.
Yeah, just following some of the changes that they're making. I don't know if anyone's done any benchmarks yet, and it's probably too early to, because, a lot of the stuff's still in flux, but from what I'm seeing, it's going to be a massive change.
That's great. And then what's something that you want to learn next? It doesn't have to be Python specific.
Yeah, I'm still on this kind of compiler journey at the moment, so I'm kind of chipping away at this compiler book, known as the Dragon book, which yeah, I mean, because it does have a dragon on the cover, but yeah, it's one of those books where you have to kind of chip in and do a chapter, and not even a chapter, actually. I can just get like through a couple of pages and then
let it settle in your brain.
And let it settle, yeah, and think about it. Or actually, the last bit I was reading, it was like about like different optimizations and stuff like that. And I was like, oh, okay, I think that makes sense. And then went to work on like, how do you visualize that and how can you create those graphs and stuff automatically? So yeah, I'm probably going to keep working on that.
Oh, great. And then I don't know if you have any calls to action or shout outs that you'd like to give.
Yeah, check out the VS Code article. It'll be the call to action. And yeah, bookmark it and then share it with colleagues and stuff. I think it's a great reference guide, something to keep handy.
Yeah.
And also, please download and check out Pyjion and run it on your code and file any issues if you get any quirky bugs or anything, so I can continue to help make it more stable. And if you want to get involved in the project, absolutely, give me a shout.
Okay, awesome. Thanks, Anthony, for coming on the show again. It's been really great to talk to you.
Yeah, it's been a great discussion. Thanks, Christopher.
And don't forget, Honeybadger. Badger, 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 mushroom, mushroom, badger, 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 a snake. Oh, it's a snake. Go to honeybadger.io to get error monitoring on your site and get that song out of your head. I want to thank Anthony Shaw for coming on the show again. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.